there is a boundary beyond which we can never see. Not because our telescopes are too weak, but because the universe itself has hidden what lies beyond it. Tonight, we are leaving Earth and traveling farther than any human journey could ever reach. Past the planets, beyond the Milky Way, through the oldest light in existence, and toward the end of the universe. Our voyage begins only 8 light minutes from home, at the Sun. Behind us, Earth becomes a pale blue point. The planets shrink into darkness, and the solar system dissolves into a cloud of frozen worlds surrounding one ordinary star. At the speed of light, reaching the edge of this planetary system would take hours. Crossing the distant Oort cloud could take more than a year. Then comes the true interstellar ocean. The nearest star system, Alpha Centauri, is more than 4 light years away. Even light, the fastest thing the universe allows, needs years to cross this apparently empty gulf. But the darkness is not empty. It contains thin gas, wandering planets, ancient dust, and the invisible gravity of the galaxy. Pull back farther, and the Milky Way appears, a barred spiral containing hundreds of billions of stars. Our entire recorded history has unfolded inside one small region of a single arm. From above, the galaxy looks serene. Inside it, stars are born, planets collide, and black holes feed behind curtains of dust. Travel 100,000 light years, and the Milky Way finally fits inside our view. But it is not alone. The Andromeda Galaxy approaches through the darkness, accompanied by dozens of smaller galaxies. Together, they belong to the Local Group, a gravitational family spread across millions of light years. Beyond it, galaxies gather into clusters. Clusters connect through enormous filaments of gas and dark matter, forming the cosmic web. Each glowing thread contains countless galaxies. Between them lie voids so immense that entire galaxies become isolated sparks around oceans of almost nothing. Now distance becomes time. The farther we look, the older the light we receive. A galaxy 1 billion light years away appears as it was 1 billion years ago. Our journey outward becomes a journey backward through cosmic history. Modern spirals give way to smaller, stranger galaxies. Quasars ignite like beacons as young supermassive black holes devour matter. Stars form hundreds of times faster than they do in many galaxies today. More than 13 billion years into the past, we approach cosmic dawn. The first generations of stars burn inside a universe still filled with neutral hydrogen. Their ultraviolet light gradually clears the ancient fog, transforming space from darkness into transparency. Then the stars disappear. We reach the cosmic microwave background, light released when the universe became transparent roughly 380,000 years after the Big Bang. It surrounds us in every direction, stretched by expansion into invisible microwaves. This is not the edge of space. It is the oldest light that can reach us. The universe beyond that glowing veil was opaque. No ordinary telescope can see through it using light. And yet, this still is not the true end of our journey. The universe is about 13.8 billion years old, but the most distant regions we can observe today are now roughly 46 billion light years away. While their light traveled toward us, space itself expanded. That creates the observable universe, a sphere centered on every observer, limited by time and cosmic expansion. There may be vastly more universe beyond our horizon, possibly infinitely more. We do not know. We cannot reach its light, and it cannot reach us today. There is no visible wall here, no final galaxy floating beside an abyss. The horizon is a limit in information, but expansion is accelerating. Far in the future, distant galaxies will cross our cosmic horizon. Their light will stretch, fade, and eventually become undetectable. Observers in our galaxy will see an increasingly empty universe. Star formation will slow as galaxies exhaust their cold gas. Trillions of years from now, the last long-lived red dwarfs will fade. White dwarfs, neutron stars, and dark stellar remnants will drift through the remains of galaxies. Occasional collisions may briefly ignite the darkness, but the age of starlight will be over. Black holes will become some of the universe's final great objects. For timescales almost impossible to express, they will persist in the dark. Then, if Hawking's prediction is correct, even black holes will slowly lose mass through radiation. The smallest will vanish first. The supermassive giants will endure the longest, fading in final flashes after timescales that dwarf the current age of the cosmos. What remains is a universe approaching equilibrium, unimaginably large, thin, cold, and dark. Particles drift farther apart. Useful energy becomes harder to find. No new stars shine. No great structures awaken. This possible ending is called heat death, not because the universe burns, but because almost nothing remains capable of change. We began beside a living planet, under a warm star, inside a galaxy filled with light. At the end of the journey, those lights are gone. And yet, the darkness gives our moment meaning. We live during the brief cosmic era when stars still shine, galaxies remain visible, and conscious minds can look outward and ask where everything leads. The end of the universe may be beyond all reach, but for one extraordinary moment, the universe is here to witness itself.